Hi, in this video I'm going to show you guys how to find the area between two curves. Okay, so what we have learned about finding the definite integrals is, for now, what we know is this. Let's say today I have this curve, and let's say this is 1, and let's say this is 5, right? And let's say this is my f of x, right? So if I do this, if I find the integral of f of x, right, with respect to x from 1 to 5, and that will give me the area bounded by the curve and the positive x-axis, right? So right now, in this video, we're going to talk about two curves. So for example, they don't necessarily have to be curves. It could be straight lines as well. So the problem here that we're going to solve is something like this. Let's say today, if I have say a straight line like that. Right, so let's say this is my g of x. My straight line is a g of x. It's a linear function. And in this scenario, what we have to do is this. They want us to find the area. So so what we're going to come across right now is we're going to find this area, right? The area bounded by the f of x and the g of x, right? So we are interested to find what's the area of that. Okay. So let's take a look. Go ahead, pause the video, and let's see what information is being given to us by the question. Okay, welcome back. So here what we have is we have two equations. We have two types. The first one is quadratic, the other one is linear, right? Then the first thing we have to do is to graph it, and then the second thing we have to do is to write the expression. Right? When you write the expression, to find the area bounded by this parabola. This is going to be a parabola, looks like that, and y is equal to negative x, slope is negative, so maybe something like that. Right? This is just a very brief sketch, maybe, and then maybe we have to find that area there. Right? So assuming that the graphs of the two equations look like that, then this area is what we have to find. All right, so let's try to do the first step, graph it. Let's try to graph it first. This is going to take a while, but maybe for this portion you can fast forward the video. If you're not sure if you want to watch how to graph a quadratic equation and a linear equation, here it is. Okay, so I know that my vertex will be at -2. My y-intercept is -2, and then when my x is equal to 1. Let's give myself a table here. I have 0, 2, 0, -2. Let's say if I have -1, -2, and this is 1 and 2. Just get 5 points and see what we have. -1, that gives me -1. That gives me 2. And then what else? If it's 1, it's -1. If it's 2, it's 2 as well. Okay. So here it is. That's it. Now, I'm going to put these points down, put these points on my graph. So 1, 2, 3, 4. This is -2, -4. Okay, so I will have -2, -1, -1. I have a point there. -1, -1. 2, I have 2, 1, 2. Okay, so 2 is 2, -2 is also 2. So I have this parabola, right? Okay, so the blue line here, this is my y is equal to x squared minus 2. Now for my y is equal to -x, so I can erase the table now. I don't need any of that. For my y is equal to -x, it will be my y-intercept is 0 and my slope is 1. So I will have this. Let me do that better. Okay, so when my x is -2, I will have +2, so there's an intersection there. Right. When my x is equal to 0, I have a 0. When my x is equal to 1, I have -1, so that's good. So you see that what we're doing here is we need to find the equation, we need to find the area bounded by the two curves. So I have a straight line and a parabola, right? This is y is equal to -x, right? Now, if you look at the graph that I have, the ugly graph that I have, which graph is on top? Is it the linear graph or is it the parabola? So the linear graph is on top, right? Because if I look at the area that we're interested in, the linear line, which is this one, that line is on top, is above the parabola, correct? So in this case, from -2 until, so the intersection starts from -2 all the way to 1, right? That's my intersection point, all the way to 1. This is -2, right? -2, and this is 1, right? So from -2 to 1, who's on top? This y is equal to -x is on top. Who's at the bottom? The parabola is at the bottom. So this is what we do. If I want to find the area, right? If I want to find the area bounded by two graphs, two curves, in this case I have a straight line and a parabola, I'll take whatever is on the top, which is this, minus whatever is at the bottom, right? Minus the x squared minus 2. And this whole thing, you find the integral of that whole chunk. Okay? -2, 1. Remember that we're always going from left to right, right? If you reverse it, you'll get a negative value. So make sure to be careful with that. This is a common mistake. Make sure you always go from left to right, all right? Okay, so let's try to do this. So this will be equal to -2, 1. Let's simplify whatever's inside. -x minus x squared plus 2, right? Distribute dx, which is equal to, so now I can just find the integral respectively. So I have x squared and I will get a -12, right? That would be the integral of -x, and then I will have this will be x cubed, and I will have a 1/3 in the front, and then plus 2x. Right. I hope you guys are comfortable finding integrals. So if I differentiate this, I get that. Right. If I differentiate this part, I get this, and if I differentiate plus 2x, I get plus 2. Right. So that's good. And I'm just going to substitute the values in here. It says no GDC, right? So we cannot use our GDC here. So let's see, we have to do this manually. So substitute the ones in there. So I'll get -12. 1 squared is still 1, minus 1/3. 1 cubed is 1, plus 2. This whole chunk minus, be careful with this, minus. So -12 times -2 squared, right? Minus 1/3. So now I'm substituting the -2 in there. Okay, so let's bring this up here. Now -12 minus 1/3 plus 2, that gives me, you can do this on scrap paper, right? That gives me 7 over 6, and then don't forget the minus. Now what's at the back? The back will be -10 over 3. So this becomes 7 over 6 plus 10 over 3, which gives me 27 over 6. And if I simplify that, I'll get 9 over 2. Okay? So the area bounded by these two curves, the graphs of these two equations, it is 9 over 2. Right? That's the area. Remember that you have to figure out you must figure out who's on top, who's at bottom, and use the top, and always use the top equation minus the bottom one. Okay? Minus the bottom one. Do that and take the definite integral of whatever you get out of that. Okay. Now, I want to point out one last point. The -2 and the 1. Where did I get that? It's from here, right? -2, 1. This is the x coordinate is -2, right? The x coordinate for this is 1. So that's how I got that. That's how I got those two upper and lower bounds. Okay. And now that's it. Now, with the calculator, it will be a lot easier, right? All we have to do, if today we have a calculator, you can put this in your y1 and put that in y2, and you can just do the same thing, right? In y1, y2, you can put that in your GDC, and the calculator is going to give you this graph, much better than what I have here. And you can use the intersection, right? Use the intersection to find the two intersecting points. From there, you have your lower and upper bound, and then all you have to do now is to use the integral function in your GDC to find your area. Right, so much faster with the GDC. All right, this is it for the video. I'll see you guys in the next one. Bye.